Hi everyone, I hope this finds you doing well and staying healthy and safe. A couple of weeks ago, I released a version of Illuminated Cloud with the new Apex refactoring, a Move Members refactoring. And at the time, I said that I was probably going to begin to focus on Apex refactorings for a while, and that's still the intention. I absolutely want to kind of go down that direction for a while. One thing that I found in the process of trying to get started on one of those is that I might need to do a couple little side quests before I do so. There are some prereqs that will make for more complete versions of those refactorings if I knock them out first. And what I'm about to demonstrate is a result of one of those. And the work I'm about to show, the work I'm going to demonstrate, is around language level enforced immutability in Apex. And if you're not familiar with the term immutability, I imagine almost everybody, if not everybody, already is. But just a quick definition, it effectively says that once a certain state is established, for example, a variable value has been first assigned, it should not be possible to change that state or to reassign the value of that variable. And there are different ways to do this that some use different language constructs. And in fact, we'll go ahead and start with an example of this right here. So here's a very simple rectangle object, and it has two different properties, and those are private, so they can only be accessed internally by logic within this class, and they are initialized through the constructor. So effectively, they are initialized and the value is set only once. I'm going to kind of hedge on that statement, but that's the intention at least. And there are public getters, so there's no public access to the state itself. It's all done indirectly through these getters. You could use properties as well, but I'm using fields in this case. You can see that the setters are commented out. We'll use those in just a moment. Let's take a look at something. So now Illuminated Cloud is telling me that the width field can be final. This is part of the enhancement. There's another language level facility called the final modifier keyword that effectively says this variable, whether it's a field, whether it's a local variable, whether it's the class level or instance level, if it's a field, once assigned cannot be assigned again. And so it is saying that this field width can be final. Now, interestingly, it's not saying the same thing about height. But this is Illuminated Cloud saying this, so we'll go ahead and bring up the context actions, and the one that it's presenting is to go ahead and add the final modifier to this field to make it effectively immutable once assigned. Now, why didn't it do that with height? And if you've looked toward the bottom of my screen, you probably already know. But let's for a moment say that we don't understand that, and we'll go ahead and add the same modifier. And in the process of doing so, Illuminated Cloud is now reporting that there's an issue with the use of that modifier. It is saying that effectively that thing can't be assigned in this context. Now here's a bug that it may seem contrived, but I've done this a couple of times, maybe more than a couple, and I'm willing to bet that most people out there have done this, and that is using the assignment operator rather than the equality operator. Oops. Now that would be reported down here properly because there would be a type mismatch. Basically, that expression would evaluate to double instead of Boolean. So that would have been detected. But when it's being used here in this expression, it wouldn't be detected until all of a sudden you say you shouldn't be able to assign to the left-hand side of this assignment expression. Again, that's what it's saying. And so we'll go ahead and fix that for a moment, and that takes care of that problem. And so now we do have that as those as immutable properties of this class using a language level construct. Now, if we tried to add a setter, it's going to tell us again that this is not a valid context to be initializing this value. You can only do that in these contexts, either at the time of declaration as an initializer, in an initializer block. That can be a static initializer block or an instance initializer block, depending upon the field itself, whether it's a class variable or whether it's an instance variable, or in the constructor if it's an instance variable. And if we were to do the same thing down here with the other setter, we would see the exact same type of a problem, and so we do. Okay, so we're getting an idea here that Illuminated Cloud helps to find things that can be made immutable based upon the usage patterns, and additionally, if something is made immutable through the final modifier and we are not honoring the general contract of that, we're trying to assign it in ways that it can't be assigned, or we're not assigning it the way that it should be assigned. We'll see that in just a moment, that it's going to tell you about that. So in fact, let's go look at some more complex examples. All right, so this is just a lot of different variants on this, and I'm not going to go through every one exhaustively, but let's go through a few of them. So here is an example where it says you can assign a value to this field that's already been initialized. And in fact, if we go to that, we can see that it was initialized at the point of declaration. And here's another example, and this was also initialized at the point of declaration. The one up here was in a static initializer block. The one down here is in a setter. Let's go down to this one and take a look. So this one's final, but it is saying, actually, for the purposes of this demo, I forgot to take this out. So this is saying that it might not have been initialized. So you can see it's being used below down here, but you can also see that no value has ever been explicitly assigned. So by default, it's going to take the default value for the data type, but that's not necessarily going to be deterministic, or it'll be deterministic, but it's not necessarily going to be obvious or explicit. And so we now have another quick fix here, actually two of them. One is to remove the final modifier so it doesn't behave as a final variable. The other is to initialize it. And so we'll go ahead and say we're going to initialize it, and it's going to do the type-specific default value and do that. And so we're really back where we started, except now it's more explicit. So that's another example of it. Let's look at some other errors. So here we have a member variable that was assigned at the point of declaration, and here we have a member variable that was assigned in an instance initializer block. And of course, it can only be assigned in one of those three, depending upon the scope of the variable. And it's not just assignment expressions. It's anything that can mutate the value of that variable or that field. So here are examples of pre and post increment and decrement unary operators. So those also count. Let's go down to the bottom and look at some other variants of this. So additionally, it is required, regardless of the flow of your logic, it is required that each discrete branch of logic initialize a final variable or a final field exactly once. So it must be initialized, and it can only be initialized once in each one of those branches. And Illuminated Cloud is now going to show you branches where there are issues very clearly. So for example, it's saying that this particular branch of logic doesn't actually initialize this final variable. And we can see that, and we can fix that. And same thing here. And so we can fix that one, fix that one as well. It's saying down here that in this branch, this else branch, this variable has been initialized multiple times because it realizes that both of these branches on this conditional properly initialize it, but then we initialize it again. And you can see that that same thing will hold if we were to contrive another example here. So you get the idea. Let's take a look at this loop down here. So this is saying the variable might be assigned in a loop. Now that's obviously a little bit softer of a statement, but if we take a look at it, we have no idea how many times this loop is going to execute. There are some loops where we could do deeper code analysis and figure out the number of executions, and we could have a more definitive statement. But in this case, and in most cases with various types of loops, with conditions being derived from starting states being derived programmatically, conditions being checked programmatically, loop state changes happening programmatically, it's really impossible to tell most of the time. And so it's just telling you this might end up being assigned multiple times. And you wouldn't find out about that until runtime. And in fact, runtime final exceptions are really something to be avoided if possible. And I'm going to show a whole class of those in just a second. This is one example. I'm going to show a whole class. There are other types of statements where you get flow control. So switch statements, for example. It's going to show you, for example, if you have when clauses that don't set it, it's going to tell you, hey, it wasn't set in this branch of logic. If it's set multiple times, same thing as we saw above. Now, one thing I'll point out, and this is perhaps a little bit odd, is if I get rid of the when else, the fall through, it's going to say that the whole statement may not have initialized the variable. Well, that is definitely true when you're switching on something that could have any number, really an infinite variety of values. Now, in this case, we're switching on a enumerated data type. Technically, if all the values that enumerated data type have when clauses, it should be fulfilled. Other languages that do this type of static code analysis require the fall through. I want to investigate that a little further. I've basically taken the perspective of I want to stand on the shoulders of giants and do what they're doing. So this behaves exactly like those other languages. If I see that it's safe to do this for things where we know the exact domain of values and you have covered the exact domain of values, I may soften this requirement and not have a requirement for an else block, a when else block, but currently it is required for all switch statements. And try catch finally. Effectively, and this should be pretty obvious, you either need to set it in the try block according to the same logic as described above. It has to be set exactly once for all logic in there, down all code paths. Or you need to set it similarly in the finally block. Now you can see it's complaining here saying it may have already been assigned because it was in the try block. The catch blocks are certainly interesting in that if you don't return, if you try to handle and recover, then they're going to complain that you might have multiple assignments. If you return to the caller, then they're not going to complain if you're trying to do the assignment in there. Hopefully that makes sense. So hopefully you get the idea here. There's a lot of control flow analysis going on in order to make sure that you're initializing and assigning values to final variables, final fields, the way that they have to be. Now, I mentioned earlier that any type of this behavior that's deferred to runtime is certainly to be avoided. Let's take a look at this. We can see that there's a very large number of errors being reported by Illuminated Cloud here, of violations of the general contract for a final variable or a final field. But let's save this class and watch what happens. And let's look specifically at what happened in this one, final modifier test. And we can see that it only reported two problems. It only reported two problems. And let's talk about those problems that were reported. So we'll go ahead and go to this one, and we'll go ahead and go to this one. So they're really two variants of the exact same type of thing, but there's so many other issues being reported. Are those false issues that Illuminated Cloud should, false positives Illuminated Cloud should have reported? Or is something happening where the compiler is not catching those? Well, it's the latter. And let's use this as an example. So I'm going to take this logic. This should be pretty straightforward. Have a variable that is set to final, assign it a value, and immediately try to assign a different value. That should fail, right? I mean, and in fact, Illuminated Cloud says cannot assign a value to initialize final variable pi. So I've brought that down here and I've instrumented a little bit with some logging. And if we execute this in anonymous Apex, we can see that we were told on line 4 that that assignment was invalid, but we can also see that the lines ahead of that actually executed. So this was deferred to runtime. You got a final exception instead of getting a compiler error, instead of having static code analysis detect this type of situation beforehand. And that is obviously the case with all but two of the types of issues being reported all throughout this class. Now, any types of issues that are deferred to runtime could potentially end up resulting in production issues if they're not detected during testing. And in this case, this is a class of issues that can be detected through static code analysis. So by moving this forward, not just from runtime in production or runtime in test, or even to deployment / compile / static code analysis on the server time, but to the IDE, you're saving cycles, you're saving runtime bugs in production, you're saving test time to find these. So this should be a big win if you decide to embrace this language-enforced immutability through the final keyword. So now let's talk about how you can actually use this in your own project. So in this case, I'm going to use an actual project. It's just Salesforce's Apex recipes. And let's take a look at how we can find existing opportunities to make things immutable that are behaving as if they're immutable, but are not actually denoted as such declaratively through that final keyword. And of course, once you catch up your code base, then Illuminated Cloud is going to do the same thing for all new instances. So you can run the control flow analysis code inspection, and this behavior has just been added to that because this is control flow analysis. And you can run it across your code base. Now, one thing I'll point out real quick is if you don't want to do this, if you don't want to buy into this, things could be made final. You'll do that selectively yourself when you feel like you want to do it, but you don't want the IDE kind of nudging you to do it. In the code inspection, you can just disable this. It's enabled by default, but you can just disable this if that's not something you want. If it is enabled, it's going to be telling you about this. But even if this is disabled, it'll tell you about the errors, all those things you saw before. It just won't tell you when there are opportunities to make something immutable based on observed usage patterns. So let's go ahead and run this across the code base. And it's going to find, in this case, 25 issues reported by the control flow analysis inspection. 24 of those are for this particular issue. Another one, as we'll see, is for a continue statement that's unnecessary. And let's just kind of walk through these. So it's going to give us a new that exact same code intention to add the final modifier, and we can do some of this in mass. So we'll just go ahead, if you'll bear with me for a moment, I'm going to go ahead and take care of that. So we'll go ahead and say add modifier, and I'm going to do this kind of across all the classes that reported this, and do it here. Unfortunately, it doesn't seem to be allowing me to do it from the top level. I'm going to try to figure out why it's not doing that. Here's that example where there was an unnecessary continue statement. So I'm just going to fix the modifier issue. And then the remaining piece there is the continue statement we can see. So we'll go ahead and move on. And only a couple of more instances of this and we'll be done. Add final modifier, and then these last couple. Okay, so we're done. And let's go to version control, and we can see that that modified quite a few things. If we take a look at those, we can see that, here were a couple of, you can see that these didn't have the final modifier. Here are a couple of lists that were initialized at the point of declaration, and they were never modified. The contents were modified through the mutator methods, but they were never reassigned. And then if we move on to another example, here is an instance variable that wasn't initialized at the time of declaration. It was initialized here in the constructor, and then it is never changed to another value throughout its life cycle, and so it becomes a candidate for being made final and immutable, which is what you want. And so now we can go ahead, and now that that's happened, we can go ahead and deploy. So I'm going to go ahead and push this. This is against a scratch org. I'm going to go ahead and push this. So our first gate to pass is, did it pass the compiler? And so there were no syntax errors effectively introduced, and given the level of static code analysis performed by the compiler, it also passed that. So that all worked. And then we know that some things are deferred until runtime. So I'm going to run all the unit tests. And assuming this passes, we should be in good shape. And this is something you can do to your own code base. Now, while that's running, I'm going to call back to something I said earlier, and that is I wanted to do this work before I moved on to some of the things I mentioned previously, like additional refactorings, other things that I've been wanting to do, like some additional smart code generation. So why is this important before I do those? Well, quite a few of those through best practices, want to make the resulting code, the resulting fields or variables, final because they are observed as being immutable and they want to effectively enforce that contract. Here's two examples. The introduce field refactoring, which takes a local variable in a method and pulls it up as a field so that it can be used more broadly throughout that class than just in that method. And when it does so, it looks at that field initialization and prompts whether you want to initialize at the point of declaration, initialize in the constructor, or initialize the same way that the original field was being initialized in the method. And if you choose one of the first two options, even if you choose the third, but specifically one of the first two, and there are no further changes to the value of that field as it was used as a variable, it will allow you to make that final and treat it as immutable. Similarly, for smart code generation, this is a great example of it. If you generate a constructor, you have the opportunity to create a constructor that takes parameters to initialize the various fields of the class for which that's a constructor. And if those fields are never mutated, if they're never if their value is never reassigned after the constructor completes, then it can be made final, and that's effectively treated as a mutable state of the constructed instance. And so by having all this infrastructure in place, not only to know about final, but to show issues with the use of final, those particular refactorings and smart code generation are just going to be that much stronger when we get to them. So there may be several side quests along the way that I do before I get to them. As I kick over other things that I think should be prerequisites, we'll see. And then I'll move back to those refactorings and smart code generation. So you can see that the test passed successfully. We're in good shape here. So that shows that this change to your overall code base to apply language-enforced immutability through the final modifier was successful. All right, so if you find any issues, this is my standard disclaimer. If you find any issues with this, with all this control flow analysis to check all the various logic branches and things like that, there may well be bugs. Almost certainly are. give me a reproducible test case, standalone reproducible test case in the public issue tracker, and I'll fix it. If the code intentions, the things that actually allow you to change the code, like add final modifiers or add initializers, if those break your code, again, same thing. Otherwise, I hope you find this useful. And I will say this. I use this concept of field and variable level, more field and variable level immutability through the final modifier or whatever the language supports. In Java, it's the exact same thing, the final modifier, extensively in my own work. I find that it results in much higher quality code, much more maintainable code. I definitely advise you to at least investigate it. Having said that, it is definitely opt-in. As I showed you, you can disable the things that are recommendations, but it should at least tell you when you are using the final modifier when you're using it incorrectly. All right, so having said all that, I hope you find it useful, and thank you very much for your time, and I hope you have a good day and stay healthy and stay safe. Thanks. Bye.